These are notes over 3.3, the third law of motion. So previously we've talked about Newton's first law, which had to do with balanced or unbalanced forces. So an object will remain at rest unless acted upon by an unbalanced force or an outside force. Okay, and then we talked about Newton's second law, which had to do with acceleration, mass, and force. Okay, so Newton's third law states that for every action, there's an equal and opposite reaction. Okay, so all of these forces that are experienced are in pairs. Okay, so for example, we have these three examples here. Okay, the first one is shooting a gun. So as you shoot a gun, if you ever have shot like a shotgun or something like that, you would know that whenever you shoot, there's recoil, okay, where the gun kind of comes back towards you. Okay, and that's because the action is that the gunpowder inside the gun creates a push or a force on the bullet, which causes it to accelerate out of the gun. Okay, but the bullet also applies a reaction force backwards on the gun, which causes the gun to move backwards. Okay, so the force is equal. Okay, and if you think back to whenever we did the adding and subtracting the arrows, the forces, okay, if they're equal, you would think that that would mean that we'd have a net force of 0. So the reason why that's not the case is because they're acting on different objects. If these forces, let's say, were equal and we had like a tug-of-war rope between, and that same rope was getting pulled equally this way and equally that way, we would expect that the rope wouldn't move, okay? But these objects are moving because the forces are acting on two separate objects, the gun and the bullet, okay? For the next one, whenever we're walking, okay, the action is that we push down on the ground, okay? And with however much force we push down, the ground's going to push back on our foot with the same amount of force. Okay, so the action is pushing down on the ground. The reaction is the floor pushing back up on your foot. Okay, so the more force that you apply downward on the ground, the more force you're going to feel upward on your foot. Okay, so that's why jumping, jumping we use our muscles a little bit, but the more force you push down on the ground, the more you're going to bounce up. Okay, so if you think about it in terms of like a trampoline, you might have experienced that the more force you push downwards on, the higher you're going to go in the air compared to if you just barely push down on the surface of the trampoline. Okay, the last one is if you are standing on a boat, if you jump off of the boat, okay, your foot is going to push down on the boat or kind of away from the boat, okay, and then the boat is going to push you forward, okay. If the boat didn't push you forward, you wouldn't move anywhere. Same thing with pushing down on the ground. If this Newton's third law didn't exist, if we would push down on the ground, we just wouldn't go anywhere. Okay, we wouldn't be able to walk because the ground wouldn't push our foot back upwards. Okay, our foot basically would just keep going through the ground. Okay, so like I said, the forces are applied to different objects, thus it doesn't result in a net force of 0.